A lot of the math that we do in this class is going to be in the form of what we call dimensional analysis. Now, the reason we do dimensional analysis is not to confuse you. It is actually to help you. It's a pattern, and if you follow the pattern, it will make solving complicated math problems much, much easier. Now, a dimension means the unit. So, for example, we can use dimensional analysis in unit conversion. Let's say we're talking about something that is 14.7 feet long, and I want to know, well, how many inches is that? Well, I know that there are 12 inches in 1 foot. This is called a conversion factor, okay? 12 inches equals 1 foot. As long as these two things are equal to each other, it's perfect. I can use it in my math problem. Now, the question becomes, if I've got something that's 14.7 feet long, do I want to multiply by 12 or do I want to divide by 12? That's where dimensional analysis comes along. So the first thing I'm going to do is put down my given. 14.7 feet. That's my given. Now what I'm going to do is I'm going to draw two lines, right, like that. This vertical line means multiplication. It's the equivalent of putting parentheses around something. And we know that parentheses means multiplication. This line here is division. Again, it's very similar to something you see elsewhere in math. We know that a line means division in, say, a fraction. 1/2 means 1 divided by 2. So that line is like a fraction line. Now, here's why it's called dimensional analysis. The dimension of the given is feet. The answer I want is going to be in inches. So that means I want to get rid of feet. Well, the only way to get rid of it is to cancel it. Again, just like in math class. Only I'm doing it with words instead of with numbers. So this feet on top here is going to go down there. Feet to feet. As long as one is on the top and one is on the bottom, I can cancel them. Inches I'm going to write on the top, because I know an equivalent. I know something that makes inches equal to feet. What is it? Why, it's this, my conversion factor, that there are 12 inches in 1 foot. Now, this does not have to be a one-step problem. I don't have to know in my head a conversion between the given and what I want the answer to be. I could do a conversion between the given and something else, then that's something else and something altogether different, and then finally the altogether different and the answer unit. It doesn't matter how many steps. The only thing that matters is the units keep canceling until I get to the unit I want. But in this case, I know something direct. I know that there are 12 inches in 1 foot. So inches is the only unit left over, so it must be the unit of my answer. See, again, this is why we're doing it. We're doing it so the units match, and then we know we're multiplying. We know we need to multiply by 12 and not divide by 12. Because if I said 12 on the bottom, that would mean 12 feet equals 1 inch, and that's, we know, is not true. It isn't true that there are 12 feet in an inch. It's 12 inches in a foot. So 14.7, this vertical line means times, so 14.7 times 12. This line means divided by, so divided by 1, which we don't have to bother to do mathematically because we know that's not going to change the answer. So the answer is 14.7 times 12, which I plug into a calculator, and I get as an answer 176 0.4 inches. And that, in a nutshell, is dimensional analysis.